Hello friends, welcome to Devrat Knowledge Villa. You are watching our English video series of operating system and learning deadlock. Today's our topic is what is deadlock. So before starting to discuss about deadlock, let first discuss few non-technical examples like suppose two persons over here, one male and female, they want to drink a soup. Suppose they have a soup. So those requires two things, which is one bowl and one spoon. Get it? So let's see. It is the bowl of soup and one spoon is available. But right now our situation is one male person is over here and one female person is over here. Get it? And only single bowl and single spoon is available to drink a soup. So what situation is going to be occur? Let's see. For example, both are coming to drink a soup and there is only one single bowl and single spoon is available. Suppose that male person is arriving and male person is taking a bowl. Get it? Look like this bowl is held by the male person, and then after same time one female person is arrived and female person will take a spoon. Get it? There was only one single bowl and single spoon. Bowl is already held by the male person and spoon is already held by the female person. So what is the next requirement of both? Suppose that male person have a bowl, so male person will require spoon, and this female person have a spoon, so this female person require a bowl. So both will put their request for the particular things. Get it? This male person will put a request for the spoon and this female person will put a request for the bowl. It means that male person will ask this female person to release the spoon and that female person will ask this male person to release a bowl. Get it? But let's see, actually right now this male person actually didn't drink a soup. Same thing, this female person also didn't drink a soup, because both are waiting to drink a soup. Both have only single thing. One has a bowl and one has a spoon. So actually they didn't complete their process to drink a soup. Get it? So they will not release their own resources. Suppose this spoon is available right now or held by this female person. So before drinking a soup, that female person will not release a spoon. When this female person will release a soup, when they complete their own process of drinking a soup, and this bowl is actually held by this male person. So when this male person will release the bowl, when male person complete their process of drinking a soup, so it is not going to be complete because both have a single thing. One has a bowl and one has a spoon. So it is not possible to drink a soup with the single spoon or a single bowl. Get it? So whenever this request of male person for the spoon, it is not going to be fulfilled because spoon is not going to be released by the female person. So this request is not satisfied. Same thing, this female person is requesting for a bowl. So same thing, this request is not going to be fulfilled because this male person will not release a bowl. So that's why this female person is not getting a bowl. It means both are holding one resources. Male person is holding a bowl and female person is holding a spoon, and male is looking for spoon and female is looking for bowl. So both are waiting for release the spoon and bowl to each other. Get it? So both will hold a single person and both requiring a one single resource. So it is not going to be fulfilled. Get it? So this request always in waiting state. Same thing, it is this request is into the waiting state. So we can say that both are continuously waiting for the spoon and bowl. Same thing, if you have seen into the movies, so if you seen the love triangle into the movies and serials, so we can say that this example of love triangle into the movies and serials are example of deadlock. Let's see, understand with the some technical things. First, we are going to take a system model. So how actually this system model is work? First, whatever the processes are available into the system, all processes request for the resources. Whatever the number of processes are there, like some processes require input devices, some processes require CPU, some processes require output devices. Whatever the requirement, every process have, these processes are, first thing, processes are putting a request for resources. That is the first step. What is second step? Suppose after putting a request, suppose processes are getting a resource. So after getting the resources, process will use that particular resource. Whatever the number of processes like P1, P2, P3, P4 and P5, 5 processes are there. So all processes will put a request. After getting a resource, all process will use that resource, and after using that particular resource, those processes will release the resource. Suppose one process put a request for the CPU, but after completion of execution, that process do not require CPU for more number of times. So that process release the CPU and another process will get that CPU. Same thing for IO device, like process P1 is holding a printer, and after completion of printing task, that process will release the printer. Get it? So these are the common fundamentals, basic 3 step. First step is request, second step is use, and third step is release. Let's see, we have a 2 processes, P1 and P2. Get it? Process P1 and process P2 processes we have, and 2 resources we have, that is R1 and another resource R2. So let's see, this resource R1 is actually held by P1. P1 is holding resource R1, and another resource R2 which is held by process P2. Actually thing is that to complete the execution of P1, P1 requires 2 resources, R1 and R2. Same thing for the completion of task, P2 requires 2 resources, R1 and R2. So both the process P1 and P2 requires 2 resources, that is R1 and R2. But right now P1 get only R1 and P2 get only R2. So that's why right now P1 will put request for the R2 and P2 will put the request for the R1. Get it? But when P1 release R1, when P1 use the R1 and R2 both, and when P2 release R2, when P2 will use R1 and R2 both. But this situation is not going to be solved out, because right now P1 have only R1. So P1 will not going to complete their execution, and same thing P2 will not going to complete their execution, because both are waiting for one resources, and that resource is actually held by another process. So we can say that this state is a deadlock state. In terms of multi-programming system, whenever processes are putting a request for resources, and if those resources are not available, so at that time processes are going into the waiting state. It means right now P1 is in waiting state for the R2 and P2 is in waiting state for the R1. So both the processes are in waiting state. But after reaching into the waiting state, suppose these processes are not able to solve the waiting state. It means P1 and P2 are unable to come out from the waiting state. It means for the infinite time P1 and P2 are going into the waiting state. So after completion more and more time, P1 and P2 will not be able to complete their execution. It means for the infinite time P1 and P2 are in waiting state for infinite amount of time. It means this situation is not going to be solved out. So that's why we can call this situation as a deadlock situation. So let's see the definition of deadlock. Definition is look like somehow a set of processes is in a deadlock state. Understand the complete meaning. Set of processes. Always set of processes are going into the deadlock state. Single process cannot lead the deadlock state. Always to generate a deadlock, set of processes require. We have already discussed whenever single process is requiring a resources, and suppose that process is not getting resource for more amount of time, so this situation we have already defined this situation as a starvation for the single process. But right now we are discussing about the set of processes. It means P1 and P2 is a set of two processes. Same thing, set of processes for the 5, 10, 15, whatever the number of digits for the process. It means always it will more than one process, not a single process. Set of process is in a deadlock state when every process in the set is waiting for an event. It means suppose right now here there is a set of two processes. So both the processes are waiting for an event. Suppose set of processes with the 3 processes, or suppose set of processes with the 5 processes. So all 5 processes are waiting for the resources. But right now here 2 processes are available. So both the processes, it means every process in the set is waiting for an event. Both the processes are waiting for resource R1 and R2, and that can be caused only by another process in the set. If suppose P1 want to use the R2 or P1 require R2, so R2 is only caused by another process in the set. It means P2 is in the set of this process. Same thing, P2 requires R1, so R1 actually caused by another process in the set. So we can define this situation like that: a set of processes is in deadlock state when every process in the set is waiting for an event that can be caused only by another process in the set. So I hope you are already understand the situation of deadlock, how deadlock is going to be occur, and what is deadlock. So guys, if you have still any query regarding to deadlock, so you can put your comment into the comment box and ask to me your doubts and your queries. Thanks for watching Devrat Knowledge Villa. Thank you very much.